In this video, I will try to prove that a function from L2 to L2 defined by this f of x1, x2, so on equal to 0, x1, x2, so on. That means this vector has been shifted towards right is continuous with respect to L2 metric. So let us go through the sequential approach of continuity. That means let's take a sequence. Let Sn equal to x1n, x2n, so on, and let's assume that this converges to S, and suppose that S is equal to x1, x2, so on. So if we have to go through sequential approach, that means we have to take any sequence which converges to this. For example, this is some fixed number in L2. That means we have to take every sequence which converges to this and their post images also converge. That means we have to prove that f of Sn converges to f of S. Since Sn converges to S as n approaches to infinity, in L2 metric, we can write d of Sn, S is equal to under root of x1n minus x1 whole square plus x2n minus x2 whole square plus so on. Since it converges to this, and since it converges to this, that means we can take this less than epsilon after some stage. That means this is less than epsilon for all n greater or equal to m. That means after this stage, this converges to this. This is the reason I have written here distance between Sn and S is less than epsilon. Now, let us check their distance between their post images. That means distance of f of Sn, f of S. That is equal to distance of f of Sn. F of Sn means we have to substitute these components here. That means I have to write here, I'm supposed to write 0, S1n, S2n, since it has been shifted towards right as by the definition of the function. That means this, I have to write it like this. F of it is x1n, x2n, x3n, and distance between this vector and f of S. F of S is 0, x1, x2, so on. And by L2 definition of L2 metric, we can write it like this: under root of plus x1n minus x1 whole square plus x2n minus x2 plus so on, and that is equal to under root of x1n minus x1 whole square plus x2n minus x2 and plus so on. Since by, let's call it star, since by star I can write this is less than epsilon for all n greater or equal to m. because this is equal to this, and we already know that this is less than epsilon after this stage. That means we have checked it out that distance between Sn and S is again, which implies distance between f of Sn is less than epsilon, or equivalently I can write limit n approach to infinity, distance between f of Sn comma f of S is equal to 0, which shows that means corresponding to every sequence which converges to S, their post images converges to f of S. That means f of Sn converges to f of S. And by sequential approach of continuity, we can say that given function which employs f is continuous with respect to L2 metric. This completes the proof of this question. Thank you.